BTEC Applied Science, Unit 1 Physics, and this video is analog and digital signals. So what are they? What's the differences between them? Why are digital signals better? Probably. So look at this, a microphone. What does a microphone do? Well, it changes sound into an analog electrical signal. So you sing into the microphone, there's stuff inside it that vibrates and it produces an analog electrical signal, which is a voltage. And this voltage can have any value. Within limits, within a range, it can have any value. The value of the voltage is continuous. So looking at this graph here of voltage against time, the value of the voltage at any time, it can be positive, it can be negative, up to a maximum, it can have any value. The value of the voltage is continuous. And this electrical signal can travel through copper wires, what we call coaxial cables. It can travel through copper wires. It can be amplified to make it a lot stronger, and then it can go to a loudspeaker and can be changed back into sound. Now, in the past, all television, ask your parents, all television signals were analog because the radio waves coming in were analog as well. Their intensity could have any value. Their amplitude could have any value. Most radio signals still are AM and FM, although digital radio is becoming more and more common now. So what is a digital signal then? Well, think of it like this. Imagine a train and there's lots and lots of carriages, and each carriage is either a 1 or a 0. Yeah, it's got 1 or a 0 written on it. So starting over here, 1 and then 0 and then 1. I should have made it go a little bit faster, but you get the idea. It's a train of 1s and 0s. Okay, and this is a binary digital signal. Binary means there's two possibilities. It's either a 1 or a 0. Yeah, it is discrete, like the analog signal was continuous. This is discrete. It can either be one thing or the other, and for a binary signal, it's either a 1, we call it a 1 or a 0, and these are binary digits or bits. Now, the digital signal could actually be a voltage. And the voltage could be high or low. And if the voltage is low, then it's a 0. If the voltage is high, then it's a 1. Yeah, if it's low, it represents a 0. If it's high, then it represents a 1. So the signal could be a voltage. It could also be, as hopefully you've watched my video about refraction and fiber optics, it could be pulses of light. So if you look, this represents a fiber optic cable, and pulses of light are traveling through the cable. And if you look at the end of the cable here, we see pulses of light. Maybe the light represents a 1, and then no light represents a 0. So again, 1, 0, 1, 0. So here's a common question which you must answer. So learn this answer. Explain the difference between an analog signal and a digital signal. So I've already said this. This is what you can learn. The value of an analog signal at a certain time can have any value within a range. It is continuous. The value of a digital signal at any time can only have one or two of two values. We call these values 1 and 0. You might want to, if I was answering this question, I would do a little sketch maybe like this is meant to be an analog signal, and you can see that it can have any value, and then a digital signal is either there or there. Yes, it can only have one of either a high or a low, and that's a 0 and that's a 1, etc., etc. And that's the difference between an analog and a digital signal. Now, how can a digital signal carry information? How can a digital signal carry like sound, like an audio track, or even pictures or text? Well, what we do is we get our analog signal, perhaps from our microphone, and there's a machine called an analog to digital converter, or rather a circuit, a computer circuit called an analog to digital converter. In the case of an audio signal, it's actually called sampling. But I'm pretty sure you're not going to be asked to explain sampling. It's quite complicated and there's enough to learn. Let's just say an analog to digital converter changes our analog signal into a digital signal, and then that can either be transmitted either through a fiber optic cable or as radio waves or whatever, or it could be stored in a computer, in computer memory. Because computer memory stores digital information. It stores lots and lots of ones and zeros. That's an advantage of digital signals, is that you can directly store them on a computer. Then, if you want to listen to your Taylor Swift album, whatever, then the signal, you either receive the signal through an aerial or through a cable, or you get it from storage from the computer, and then you use a digital to analog converter, which is a clever circuit which changes it back into an analog signal. Okay. How do they travel through fiber optic cables? I've talked about this in another video, and it's basically total internal reflection. And you should remember from my other video, you should remember that if that angle there is bigger than a certain value called the critical angle, then the ray of light will reflect. It won't escape, it will reflect, and so it gets trapped inside the glass fiber and comes out of the other end. Why fiber optic cables? Why are optical fibers carrying light better than copper wires carrying electrical signals? Well, glass is very cheap, and glass fibers are much, much cheaper than copper. Copper's getting more and more expensive, and glass fibers are a lot lighter. Yeah, copper wires are very, very heavy. Another advantage is that the signal doesn't need to be boosted as often. As the signal travels along, it will naturally get weaker and weaker as some of it is absorbed. And so every now and then you will have to boost the signal. With a signal going through an optical fiber, you don't have to do this as often. So, why are digital signals better? And I'm going to give you two reasons. I think you should learn two reasons. The first reason, a digital signal can carry much more information than an analog signal. Okay, here's a fiber optic cable, and a fiber optic cable can carry a broadband signal. What does broadband mean? Basically, it means lots and lots and lots of information. Lots of different signals can be transmitted at the same time. The internet signal going into my computer is from a fiber optic cable. Okay, lots of different signals can be transmitted, so high-speed internet access is a broadband signal. Typically 100 megabits per second. 100 mega is 10 to the 6, that means a million, so that's 100 million bits of information per second. So that's the first advantage, much more information. It can carry a broadband signal. And remember, broadband basically means lots and lots of information, okay? The old analog televisions, you had 3 or 4 channels. Digital televisions now, there's a couple of hundred channels, and it's high quality HD television with stereo sound. Tons of information. So that's one advantage. Another advantage, another reason digital signals are better, is that when signals are transmitted, they often pick up noise. And noise is stuff in the background which will affect the signal and change the signal. So it's noise due to external interference. And if you look at this diagram here, there's a digital signal without any noise, and then my digital signal has picked up some noise, but it's not a problem. It's not a problem because you can still clearly see that that's meant to be a 0, and that's meant to be a 1, and that's meant to be a 0. What you can actually do is put this signal through a filter, and it will just get rid of the noise. So it's easier to get rid of the noise because it's easy to recognize the noise. If you had a lovely analog signal, there's a little analog signal. Now, if that picked up noise, I'm adding a bit of noise to my analog signal here. The problem is it noise or is it meant to be there? Is this bit here, is that noise or is it meant to be there? And if you take away that bit, if you filter that bit out, you could be losing part of your signal, probably the high frequency stuff. So when signals are transmitted, they often pick up noise due to external interference. And despite the noise, it's still easy to recognize 1s and 0s. So you don't lose information with a digital signal.